G'day, welcome to Mr. Hannah's Math Methods Units 1 and 2 channel. Hopefully you'll find this a very useful resource when looking at your maths methods work. Okay, so this first video we're in the chapter all about linear equations, so some of this will be revision work. But a linear equation is basically an equation that looks like this: y equals mx plus c, where m is the gradient and c is the y-axis intercept, the y-intercept. So, by the way, the gradient is just a fancy word that means the slope of our line. And a possible look for a linear equation will be something along the lines of this. So linear basically just means a straight line equation. Okay, so important things to know about straight line equations: they will always cut through the y-axis at least one point. So that's our point C there. And they'll also cut through the x-axis intercept at one point. So there's some key things that if you sketch it, you always need to include those important points. Okay, so like I said, this video is actually about solving linear equations, and you can use some of these techniques for solving other sorts of equations as well. So let's just start off with a couple of examples, because this stuff you should have probably already covered in the past, but let's do it again. So here we go. We have to solve 3x plus 4 equals 22. Now whenever you're solving an equation, there's just three things you need to remember. You need to remember that you need to undo it in the opposite order. Undo in opposite order. So what that means is here, if we started with x, what happened to x was they multiplied by 3 and then they added 4. So what we've got to do to solve it is first we'll get rid of the add 4, because that's what happened last, and then we get rid of the times 3 because that's what happened first. So we undo in the opposite order. Okay, the second thing we need to remember is we always have to do the inverse operation. Okay, so what I mean by that is if we did a plus, we need to minus. If we had done a times, we need to do a divide. And there are some other ones as well. Okay. And the third thing we need to remember is we can do anything, but we need to do it to both sides. Both sides. Okay? So undo in the opposite order, use the inverse operations, and do whatever you do to both sides of the equation. So let's do it. First, we'll get rid of the plus 4, because it happened last. So to get rid of the plus 4, we need to do a minus 4, and we need to do it to both sides. So now on this side, the plus and the minus 4 will cancel out, and we've got 3x equals 22, take away 4, 18. Okay, so that's one step. Now we repeat our three things again. So first we undo in the opposite order, so we need to undo our times 3. We need to do the inverse of times 3, which is a divide by 3 to both sides. Divide by 3. And we do it to both sides. So the 3's cancel on this side, leaving us just x. And on this side, we've got 18 divided by 3, which is 6. So there's our answer, x equals 6. Okay, let me do one more of these style ones. I'll just do it over here. And I might do this one a little bit quicker. Okay, with this one, the first thing I notice, this is a bit of a different one. The first thing I notice is that I've got x's, I've got unknowns on both sides. So first off, I need to put them all on the one side. So to do that, I'm going to take away 3 x's from both sides. So I'm going to take 3 x's away from that side and take them away from that side, giving just x on this side. So let me write that again. We've got x plus 3 equals minus 5. Now I've got to get rid of my plus 3, so I'm going to do a minus 3 to both sides. So the minus cancels out, and here we've got a minus 3. Minus 5, take away 3 is minus 8. There we go, all done. Alright, next up, the next thing I want to show you is solving inequations. Inequations. Now, what an inequation is instead of having an equal sign, so we don't have an equal sign anymore, we now have either a less than sign, or a greater than sign, or a less than and equal to sign, or a greater than and equal to sign. So let me just show you, like this one here, the less than sign, that would mean like 2 is less than 3. Or let's try the greater than or equals to sign just to show you, if I said that x is greater than or equal to 4, that could mean that x could be 4, because that would be the equals, or x could be 5, or x could be 6, or x could be 4.123. Okay, because x is greater than or equal to 4. So the question that we're going to be dealing with here is how do we actually solve an inequation? So once again, I'm just going to do some examples. So let's solve 6x minus 2 is less than 20. Actually, let's make it less than 22. Less than 22. Okay. So the key with this is you solve it exactly the same as an equation, but if you ever have to divide or multiply by a negative number, this symbol swaps around. So I'll show you how this happens. So first we'll get rid of this minus 2 bit here, so it's just 6x is less than, we add 2, so that's 24, and then we divide by 6, so x is less than 4. And we're done. That was pretty easy. That one worked exactly like a normal equation. Let's try one that's a little bit more complicated. Let's solve negative 3x plus 7 equals 37. Oh, whoops, not equals, sorry. Is larger than or equal to 37. Okay, let's try and solve this one. So first we have to get rid of this plus 7. So we'll do a minus 7 to both sides. It's greater than or equal to 30. Now here, I've got to divide by minus 3. But minus 3 is a negative number. So when I do divide by a negative 3, I get x. And over here, dividing by negative 3 gives negative 10. But because it's a negative number that I've divided by, I need to swap my symbol. This needs to be swapped. There we go. So now x is less than or equal to negative 10. So let's check if that works. Let's put a possibility into our first equation. So in other words, if x is less than or equal to minus 10, that means one possibility is when x is equal to minus 11. Let's see if this works. So I'm going to put it into my first equation here. Minus 3 times minus 11 plus 7. And hopefully that is larger than or equal to 37. So let's see if that works. Minus 3 times minus 11 gives positive 33 plus 7, which equals 40. And yes, 40 is larger than or equal to 37. It's larger than. So that is a good thing, and it means our answer is going to be correct. Excellent. Okay, last couple of things for this video. And alrighty. So now we're going to be dealing with some substitution cases. So often you'll get questions that are a bit like this. If we have y equals 5x plus 2, what is y when x equals 3? And another question could be, what is x when y equals, when y equals 0. Okay, so here what we've got to do is, before solving the equation, we need to substitute in the information. So here it says what is y when x is 3. So we put 3 in for x. So we still don't know what y is, but x is 3. 5 times 3 plus 2. 5 times 3 is 15 plus 2. So y is equal to 17. Now for our second one, what is x when y is 0? It's the same thing, but this time we know that y is 0. So put 0 in for y. 5x plus 2. Now we need to solve this. So first we'll take away 2 from both sides, and then we divide by 5 from both sides. So that's x is equal to minus 2 on 5. And in methods, you leave things as a fraction, okay? No decimals. Fractions are good. Fractions are good. So that is the full and correct finished answer. Okay, one other thing in methods is that you'll be learning to use function notation. Okay, and I'm going to show you just a part of function notation now, because it's very, you need it to use our CAS calculators. So what function notation is not using the y equals sort of notation anymore. It's now using function notation, which is f of x equals, and then something, 7x minus 10 for now. So you see that we've got an f of x instead of a y. And what this means is it's some sort of function, and it depends on x, because x is our variable in there. So now instead of asking a question of what is y when x is 3, our new question that asks the same thing is what is f of 2, might be an example. What is the function of 2? So if x is 2 there. So here we just write it out, but x is now 2. 7 times 2, 14, take away 10, is equal to 4. So it's kind of like saying, it's the same sort of thing as saying that y is 4 when x is 2. But we've used these different symbols. And you can also have one like this, a what is x sort of one. So your question might be, what is x such that f of x equals 11. Okay, so similar thing. We know that our f of x is 11, so we can write 11 equals 7x minus 10. Now we've got to add 10 to both sides, so that gives 21 equals 7x. And now we've got to divide both sides by 7, so that's x equals 21 over 7, and 21 over 7 is 3. So there we go, x is 3. So there's some introduction to function notation, and you'll be using this in particular whenever you use your CAS calculator. So if you grab out a calculator page on your CAS calculator, and you wanted to solve this same problem here, this function notation problem. So f of x is 7x minus 10. What you've got to do first is define your function. So you've got to go menu, actions, define, and we'll call it f of x. And we want f of x to equal 7x minus 10. It was 7x minus 10. We press enter and it says done. That means this has been saved into the memory of our calculator. And whenever we want to remember it, we can just write f of x and press enter, and it will say, silly thing. Just one sec. Here we go. So we type in our function of x, and there we go. It sends us back what we'd typed in for our function of x. Now, as before, if we wanted to know what our function of 2 is, and we know the answer should be 4, we can just type in function of 2. And there we go, we get 4. And in fact, we can type the function of any number and it will tell us the answer. So we could do the function of 385, and there you go. Okay, for our next question, when we wanted to know what x is for our function to be 11, it's a little bit more complicated. We're actually solving for x. So we need to go to menu, we're doing algebra here, and we need to solve. So we go solve, and then we type in the equation that we're solving for. So that's, we want to know that f of x, we want that to be 11. And lastly, we need to tell the calculator what the answer should be. So we need to say comma x, because we want the answer to be x equals something. And you see that our function is in terms of x here. So we need our answer to be x equals. So we need comma x, press enter, and there you go. X is 3. Just like we had the answer over here, x being 3. So there we go. So with calculators, remember, you're going to define your function. And if you want to find out what the function equals when x is something, you just type in f of whatever the number is. And if you want to do the other way around, you need to use their solve function for that. So there you go, there's a bit of an introduction to some solving linear equations. I'll see you in the next video.